So let's get started with our lesson of today. Welcome to the 8th module of the Master in Innovation Management of Ascheri Academy. As always, I wish you a pleasant, enjoyable, and instructive experience. In this module, we will study the Internet of Things, and in particular, we will discover the interconnection of intelligent objects. With this slide, I wanted to make a little presentation of the entire technology of the Internet of Things. The Internet of Things is transforming our physical world into a complex and very dynamic system of connected devices on an unparalleled scale. Advances in technology are made possible through a widespread adoption of IoT, from pill-shaped micro cameras, for example, that can pinpoint thousands of images within our body, to smart sensors that can assess the conditions of crop in a farm, for example, or to the smart home devices that are becoming increasingly famous and increasingly popular. Over 9 billion of things, so physical objects, are currently connected to the internet until now. And in the near future, this number is expected to grow, is expected to rise to a whopping 20 billion. Let's do also a brief historical line of the Internet of Things technology. The concept of adding sensors and intelligence to physical objects was firstly discussed in 1980s when some university students decided to modify, it's very entertaining, this news, to modify a Coca-Cola vending machine in order to track its content remotely. But the technology at that time was very limited, was bulky, expensive to be realized. The term Internet of Things was coined so later, in a later stage, in 1999, by the computer scientist Kevin Ashton. He was working at Procter & Gamble, and he proposed to put radio frequency identification chips on products with the scope to track them through the entire supply chain. And then he added the important, the meaningful word internet into his proposal in order to receive the attention of managers, executives, and experts. Over the next decade, the public interest in IoT technology began to develop, began to take off as more and more connected devices came into market. Other historical points that we can mention, for example, in 2000, LG, the company LG, announced the first smart refrigerator that is able, I don't know if you have already seen this characteristic refrigerator. This refrigerator is able to check the content of in terms of food and beverage, and in 2007, the first iPhone was launched. By 2009, the number of connected devices exceeded the number of people on the planet. So we are talking about huge amount of electronic devices. In 2009, Google started testing driverless cars, and in 2011, Google's Nest smart thermostat hit the market, which allowed the remote control of our central heating. Statista, the famous company of researches, forecasts even that around 50 billion IoT devices will be used by 2030 across the entire globe. But let's present also some practical definitions of IoT. This term refers to the interconnectedness of physical devices, such as appliances and vehicles, that are embedded with softwares, with sensors, and above all, connectivity that enable these objects to connect and to exchange data. So this specific technology allows for the connection and sharing of data from a vast network of devices, and in doing so, it creates opportunities for more efficient and more automated systems. Hence, we can say that Internet of Things is the networking of physical objects that contain electronics embedded in their architecture in order to communicate and sense, experience interactions amongst each other or with respect to the external environment. So when we speak about the Internet of Things devices, we intend physical objects with this specificity of containing electronics embedded in their own architecture, and with this specific electronic architecture they can communicate and share data and sense interactions amongst each other, but also they can communicate and sharing data with the external environment. In order to better understand the architecture of the Internet of Things technology, we can describe some key components that are contained in this typical scheme, typical technological arrangement. Firstly, we're going to speak about IoT sensors. So the most significant characteristic of sensors is their ability to convert information collected from the entire network, the entire IoT network, into data for further analysis and processing. The second element is the ensemble of IoT actuators. So both sensors and actuators are transducers, which means that they can convert the signals that they receive from one form to another form. But instead of sensors, which track data provided by the electronic devices, the actuators are responsible for materially performing actions. Another element of this arrangement is the IoT gateway. The IoT gateway is a simple device that is used for an elementary, for a basic form of data analysis. The fourth factor of the IoT structure is the IoT connectivity, very important in this whole technological arrangement. End devices, so the final point of this structure, so end devices, electronic devices, and servers can be connected by cellular or satellite networks or through Bluetooth, Wi-Fi, Ethernet, and also low power wide area networks. The other element, and also the last one, is the IoT platform. An IoT platform is a middleware between the hardware-related layer, the perception and network layers on the one end. Don't worry, because we will see these layers later. So the hardware-related layers and the application layers on the other end. So it is a multi-tiered, multifaceted, complex and articulated technology that helps in gathering, in storing, in processing, and also in the important part of the visualization of data. This kind of platform facilitates also the integration of data with other parts of the entire value chain, like, for example, the data stored in the cloud or in the end user application, so in the application possessed, used by the customer. As I was saying, we have also to briefly study the fundamental layers of an IT architecture, because in the technological structure that we have seen in the previous slide, there are some levels of employment, some level of usage that are foreseen for this kind of technological approach. The first level that we have to develop in a similar architecture is the perception layer. The purpose of this layer is to interact with the physical world through the IoT devices, so the electronic devices integrated with sensors and actuators. The second level, the second echelon of this entire structure that we have to reckon with is the layer that intends to conduct a fundamental, a primary analysis of data gathered by sensors, using IoT gateways, and in this way communicating that data to a server for further processing, for further analysis, also we can say, over communication protocols like MQTT. Don't worry, because MQTT is an acronym that means the message queuing telemetry transport, but basically is a standard messaging protocol for the Internet of Things, so don't worry. The third application that we have to insert in a certain architecture that refers with the IoT technology is the application layer. This layer provides an interconnection between the above two hardware-related layers that we have discussed, and business applications that render the entire service specific for the usage of customers. So the final stage, the final level of interaction is this application layer, and serves to render more useful, more commercial, we can also say, the application for the benefit of customers, of users. Let's watch this introductory video about the Internet of Things. Surely you will find other elements, other description that are useful for our lesson and for your benefit.
The Internet of Things, or IoT, is influencing our lifestyle from the way we react to the way we behave. From air conditioners that you can control with your smartphone, to smart cars providing the shortest route, or your smartwatch, which is tracking your daily activities. IoT is a giant network of connected devices. These devices gather and share data about how they are used and the environment in which they are operated. It's all done using sensors. Sensors are embedded in every physical device. It can be your mobile phone, electrical appliances, vehicles, barcode sensors, traffic lights, and almost everything that you come across in day-to-day life. These sensors continuously emit data about the working state of the devices. But the important question is, how do they share this huge amount of data, and how do we put this data to our benefit? IoT provides a common platform for all these devices to dump their data and a common language for all the devices to communicate with each other. Data is emitted from various sensors and sent to IoT platforms securely. IoT platform integrates the collected data from various sources. Further analytics is performed on the data, and valuable information is extracted as per requirement. Finally, the result is shared with other devices for better user experience, automation, and improving efficiencies. Let us look at a scenario where IoT is doing wonders. In an AC manufacturing industry, both the manufacturing machine and the belt have sensors attached. They continuously send data regarding the machine health and the production specifics to the manufacturer to identify issues beforehand. A barcode is attached to each product before leaving the belt. It contains the product code, manufacturer details, special instructions, etc. The manufacturer uses this data to identify where the product was distributed and track the retailer's inventory. Hence, the manufacturer can make the product running out of stock available. Next, these products are packed and parceled to different retailers. Each retailer has a barcode reader to track the products coming from different manufacturers, manage inventory, check special instructions, and many more. The compressor of air conditioner has an embedded sensor that emits data regarding its health and temperature. This data is analyzed continuously, allowing the customer care to contact you for the repair work in time. This is just one of the million scenarios. We have smart appliances, smart cars, smart homes, smart cities, where IoT is redefining our lifestyle and transforming the way we interact with technologies. The future of IoT industry is huge. Business Insider Intelligence estimates that 24 billion IoT devices will be installed by 2020, and IDC predicts that IoT revenue will reach around 357 billion in 2019, resulting in a lot of job opportunities in the IT industry. Want to become a part of the IoT revolution? Come and master IoT with Edureka.
So another fascinating description about the potentiality, the huge potentialities of IoT technologies. For better describing this fantastic technological progress, we can mention, as we have seen, smart cars, smart appliances, smartphones, smart watches, and so on. But the very basic factors that you have to remember are that these technological instruments are embedded with sensors and actuators. So when the electronic device is endowed with these two technological characteristics, we are in the presence of an IoT product. The sensors, just to remember some information, the sensors serve for emitting data and for a basic elaboration of data received, and the actuators serve for the physical action of the appliance or the instrument. Let's move on with our lesson. Just a second.
The Internet of
This simple model, this simple picture illustrates to you some possible IoT applications and some business use cases. We can find IoT applications in smart homes, in the construction of wearables, in the smart city, in the useful smart grids, in the industrial internet, in the connected car, for example, in instruments related to connected health, so for maintaining the health of population, in the sector of smart retail, for the smart supply chain, and also the IoT applications are used in the field of smart farming. Let's stress also the most important benefits of the IoT technology. The first characteristic that I want to stress surely is the safety. In fact, with the introduction of this advancement, people are exposed to less hazardous environments, especially when we are dealing with applications that measure the temperature, the humidity, the quality of air, the air pollution, and so on. The other benefits regard the entire society in its complexity, in its diversity, because through the utilization of IoT, it's possible to monitor the health of population and the condition of their social care. The third factor to be considered with the insertion of the IoT technology is the environment. So we can check pollution levels, air quality, and also we can monitor the danger of flooding, for example, in some lands, for example, that are exposed to this kind of physical danger. Another factor very important with the progress of IoT is surely the innovation. In fact, new products, new service, new job opportunities, and new markets are created with the extension, with the further development of this kind of technology. Another field very promising that we can reckon with is the business intelligence. In fact, it allows the gathering of data that serve to make better decisions, in this way benefiting the entire organization. Also, on the point of view of compliance, there are many effective ways to monitor and to report and to observe, we can say, strict compliance requirements, for example. A relevant point to be stressed is the point of profitability, because IoT permits cost savings and increased productivity. In this way, the pathway can lead to the increased profitability. The other element to be observed with the introduction of the IoT technology is certainly the productivity of companies. So it can foster the identification of, for example, objectives of gains, objectives of market competition, for example, and in this sense, it can eliminate also some process errors. The last point to observe, to stress about the potentiality of IoT is its efficiency. In this way, in fact, we can have a better use of time, and the entire technology can speed up operations of companies and all the entire processes associated with production. But there are also some challenges and some risks to be considered with the introduction of IoT. The main field in which we have to be attentive in introducing IoT technology is certainly the field of security. Because you can imagine that huge amount of data are daily transferred, are daily processed, are daily stored and analyzed for the business sake. So for the sake of businesses, for the sake of companies, for the sake of industries. So the security is probably the most important domain to regard very attentively. The first issue in this field to observe is the identity management. So it's important to avoid any identity theft with the dangerous usage of data. Another point to observe is the data integrity, to preserve this data integrity. So it's important to maintain the confidentiality of data received and to avoid data breaches, for example. It's important. Another instance to stress is the system availability, because all the systems, all the technologies that we are talking about are technological advancements that have to be maintained 24/7. So a proper establishment of maintenance is required. So also the system availability is something that we have to strictly follow. The other point in the field of security is the supervision issue. In fact, with the SIEM system or the SOC system, that are different security incidents and management of, for example, breaches of, in case of, for example, in data theft, for example, entails different strategies for monitoring a network environment, and they work together in order to help corporations to prevent potential cyber events. So this kind of platforms or this kind of systems have to be put in place in order to avoid potential cyber attacks. Other two instances to be respected regards the partner and interface security and the transport communication in the network security. Let's watch this other interesting video.
The Internet of Things digitizes physical assets, sensors, devices, machines, gateways, and the network. It connects people to things and things to things in real time. A typical Internet of Things network can grow rapidly, resulting in an exponential increase in the variety, velocity, and the overall volume of data. This data opens opportunities for significant value creation and revenue generation. But the real challenge for Internet of Things environments is how to analyze the large volume of information from all sources and take action in real time. What does this mean for you? The complexity of Internet of Things combined with the high expectations created by the Internet, mobile, and 24/7 IT environment has made the need for new analytics approaches and technologies more urgent. Achieving desired business objectives requires the ability to act in real time to take advantage of opportunities and address problems quickly. In the pre-Internet of Things era, an issue in a typical supply chain scenario could be addressed in 2 to 3 day cycles for satisfactory results. But in Internet of Things, time to action is in minutes, seconds, or microseconds. 30 minutes to provision electric service, 30 seconds to act on information from devices, 5 milliseconds to address a security breach. This explosion of data and the high expectations in the Internet of Things environment means the value of data will slip away quickly. The importance of time to action for Internet of Things applications can be seen in a wide variety of applications and use cases. Broadly speaking, these applications can be grouped into 3 categories. 1. Operations and fulfillment are a convenient place to prove out efficiency gains. 2. Customer-focused sales and marketing applications have the potential to increase customer satisfaction and long-term growth. 3. Innovation in new products and services can drive new revenue and business value. There are also specific use cases within these applications. Predictive maintenance, demand and supply optimization, predictive one-to-one marketing, outage management. Addressing the critical time-to-action requirement for these use cases and applications in Internet of Things demands an advanced analytics solution that 1. Unifies historical, real-time streaming, predictive, and prescriptive analytics, and 2. Provides faster analytics and smarter actions.
So the first point that I want to comment with you is the explanation of the Internet of Things network that this video has brought in this occasion. The IoT network constructs an environment in which we can connect people to things and also things to things. The second element that regards the potential business benefits that I want to stress is the classification of the 3 groups in which the IoT technology can do its best. We have the area of operations management, we have the area of sales and marketing, and lastly, the domain of research and development. So in all these categories of business, we can exploit the benefits of this new technology. Just a second. In the further slides, I wanted to connotate the Internet of Things. So I insert the explanation of this technology in the most important business field of today. The first sector in which I wanted to explain the IoT technology is the sector of data collection. It's important to know that there are 3 types of data collection for the usage of Internet of Things technology. The first data collection is the equipment data. So this is the type of data that concerns the current status of the IoT devices. So equipment data is collected in real time in order to facilitate activities of predictive maintenance. So it's very important, for example, in case of industries that use this kind of technology. As a result, it saves the system lots of energy costs while enhancing at the same time machine productivity and longevity. The second type of data collection is the sub-meter data. So sub-metering allows property owners to automate the measurement of individual utility usage in an environment constructed by multi-user exploitation. Sub-meter data can be collected, for example, in buildings where multiple tenants use resources like water, electricity, gas, or cable. So digital sub-metering devices reduce the costs associated to the process of measurement, the cost associated to the errors, and also this digital sub-metering device can improve the timeliness during the billing process. The third kind of data collection is environmental data. So IoT sensors can measure and can monitor environmental data such as humidity, temperature, movement, air quality. These streams of data, so these collections of data, serve as a basis to track physical work conditions, for example, but also for avoiding natural calamities in case of floods or air toxicity, for example. The second business domain that I want to interpret from the point of view of the usage of IoT is the data analytics. And I took this simple model elaborated by Gartner Incorporated, by the company Gartner, because it opened the model with this important question: what makes IoT analytics so different from the other kinds of data analytics? In the domain, in the issue regarding the issue of more data collection, we can say that IoT data analytics provide high volume, continuous data in motion that can come from multiple sensors. Regarding the storage capacity and also the possibility of blending and managing time series data, IoT analytics has no other competitors. For the instance of more complexity, we can say that through IoT analytics, it's possible to use multiple analytics techniques. And also through this usage, this particular application of IoT analytics, there is the possibility of foreseeing the exploitation of the power of edge computing. So we pass from a traditional data analytics to distributed analytics with an approach to edge computing. So we can mention the brilliant characteristic of edge computing that is able to collect, to store, to elaborate data from the very source of where they are produced. The third aspect that we can remember in comparison with other data analytics technique regards the possibility of assuring more automation. So it's very important for industries, for example. So we can mention the possibility of integrate the operation systems with business process management systems through the IoT analytics, and also there is this possibility of bidirectional communication and control of endpoints, so control of the last part of the IoT entire network. Another sector in which I described the IoT is the sector cloud computing. As we have studied in our previous lessons, cloud computing offers a wide range of services. But in this case, thanks to IoT, we have the possibility of more complex and more thorough data storage, data processing, and data analyzing. So cloud computing allows also IoT device users to have common computing tasks using services that are entirely provided over the cloud, so over the internet. And it's very, this factor is very important, not only for companies, not only for businesses or for industries, but also for individuals. In fact, integrating IoT and cloud computing, for example, in an enterprise environment, is very cost effective. The enterprise does not have to own, to possess all the devices, all the platforms, all the software, all the services needed for a certain product, a certain service that is sold, for example, by the company, but the enterprise can hire them from the cloud service provider. The individual case, the individual business case, we can say, is described, for example, by the possible mobile IT devices that are normally used in our modern world, such as smartwatches that are able to collect data at different locations and may need to access this data collected at any time. Also, in this case, the cloud, so the internet, enables the devices to store data and eventually to access it from any location around the world. So many benefits, many costs savings for enterprises and also for individuals. Another promising aspect of the possible usage of Internet of Things is the artificial intelligence. Realizing the future and full potential of IoT devices will require many investments, many I dare to say expensive investments in new technology. But the convergence of AI and IoT can redefine completely the way in which industries, businesses, and economies function. So AI enables IoT in creating intelligent machines that, as we have already seen in our previous session, that simulate smart behavior, that simulate human reasoning, human behavior, and also it enables in supporting the process of decision making with little or no human interference. So the common person, but also specialists, experts, professionals alike can benefit from the combination of these two technologies. While IoT deals with devices interacting using the internet, AI makes the devices capable of learning from their data and from their experiences. So I cordially suggest you to observe the development of this promising field composed by the combination of AI and IoT, because I think that there will be many progresses, and there will be also many job opportunities. The other domain in which I wanted to connotate the IoT technology is cybersecurity. In fact, one of the primary challenges to securing the IoT is unfortunately, for the moment, a lack of comprehensive standards. This is due in large part to the complex ecosystem that is composed of a wide range of devices from a large number of companies and manufacturers. So so it's very complicated until now by the fact that securing the IoT requires, we can say, the securing of standard, scalable, and interoperable systems. But anyway, whatever are the ecosystem used, whatever are the devices or the companies or the manufacturers, we can say that the IoT application, the IoT industrial applications and devices must provide at least three key capabilities. The first capability is the capability of detect, so the ability to know what IoT devices and components are connected to a given network of systems. The second capability is the capability of authenticate, so the ability to verify the correct provenance of IoT components and also to prevent in this way and detect spoofing. The third capability that has to be assured by any industrial IoT application and IoT device is the capability of update. So IoT security programs must in any way include the ability to securely maintain and upgrade these components. Another promising, brilliant field that I wanted to show you today is the field of smart homes that you have certainly heard in some way. A smart home is a household with internet-connected appliances you can remotely control using a tablet or a smartphone, a simple smartphone. It uses smart devices like smart TVs, smart thermostats, or smart air conditioners, or even some types of robo vacuum. They are connected together in a single network through either hardwired or wireless systems, like, for example, Zigbee, Wi-Fi, through Bluetooth, near-field communication, that is another kind of little distance network, among others. By using the Internet of Things technology, your smart appliances, like, for example, the dryer, the washing machine, some cooker, for example, can communicate and can share real-time data with each other. So this allows the device to perform scheduled and automated tasks. So I think that for those of you that are particularly busy with their works, with their daily commitments, this field of smart homes, so this possibility of remotely control the smart appliances is something that is very exciting for those of us, those of you, or those of us that are particularly busy. IoT on gadgets, bounce data back and forth with the use of sensors, learning and processing your habits, your patterns, your daily usages to automatically adjust themselves for your benefit, for your comfort. As I was saying, I can mention dryers, cookers, washing machines, but also some systems of automatic light switches, or burglar alarms, or some voice-activated sound systems. Another domain that I wanted to illustrate with the insertion of the IoT technology is the domain of smart cities. Smart cities use IoT devices such as connected sensors, lights, and meters to collect and analyze data. So the cities use later this data to improve their infrastructures, their public utilities, and their services. And we can say that smart cities have the goal to provide a more efficient and a higher quality lifestyle for their residents. Smart city devices work to make their task easier and more effective, and also they work by controlling, by relieving pain points associated to public safety, for example, to traffic and to environmental issues. There are some typical smart city technologies like smart utility meters, smart grids, smart waste management solutions, and smart air quality monitors. The last connotation that I wanted to convey to you is for the sake of our today lecture, is the smart transportation. Smart transportation refers to the integrated application of modern technology and management strategies into transportation systems. So with this term, we mean the basic management systems that we are already accustomed to, such as car navigation, traffic signal control systems, automatic number plate recognition, and speed cameras for promoting safer driving, and also like a prevention method. This is an explanatory and final video that I want to show you, in which you can recollect, you can remember all the IoT technologies that we have spoken about.
The future of IoT technology. Today, more businesses are taking advantage of and acknowledging the benefits of IoT than ever before. Machine learning, AI, instant feedback and remote monitoring and operations are not merely the future, they're already here, and they're showing no signs of slowing down. With the explosive growth of IoT uses and adoption, there are some great opportunities for businesses who joined the IoT revolution early. The corporations who manage to transform and empower themselves through the benefits of IoT could create undeniable competitive advantages. As we look forward to 2020 and begin to understand the impact 5G will have across all industries, the implementation of IoT solutions will play an increasing role across business applications and throughout the community. Even though some common IoT current trends are quite visible across all the industries, the industry-specific foresight should not be ignored. The Internet of Things technology is steadily growing, and therefore IoT trends are something that always needs to be watched out for and kept pace with. 7 Trends of IoT Technology in 2021. 1. Growing 5G. In this new communication system, the 5G aims to connect networks online by providing improved wireless connectivity. 5G has been developed in a unique way, enabling it to connect more devices at higher speed with minimal lag. This cellular IoT application is created to benefit consumers at a low cost as well as provide faster speed. With the use of this new application, we will be able to see complete automation in many industries with the help of smart grids. 5G will evolve to include bigger devices over larger areas in the upcoming years. Connecting smart cities to even wireless vehicular connectivity, this future application of IoT will help the public and private sectors to gain optimal benefits. The use of 5G will make it viable to control even a broader range of devices remotely via applications. Together, IoT and 5G are setting infrastructure for smartphones and tablets, as well as wearables, medical devices, and vehicles. 2. Augmented reality, and IoT. The bond between IoT and augmented reality, keeps getting deeper. While IoT fills a gap between physical assets and digital infrastructure, drives digital components to real life. That's great teamwork. And IoT have a big future in healthcare. For example, surgeons can use an application composed to rebuild a body part in 3D along with devices measuring necessary stats in a real-time mode. All these could make complicated procedures easier for surgeons and more secure for patients. 3. Smart cities on the rise. Smart city technologies are a huge rage at the moment, with interest and investment in smart city technology slated to skyrocket in the near future. Local authorities and city councils see smart city solutions as a powerful way to involve the public in the nitty-gritty of city administration and upkeep. Increasing citizen comfort and convenience is just a small part of the deal. What we're seeing with smart city projects around the world is a strong emphasis on interactiveness. There is a growing acceptance that involving citizens in a more hands-on fashion, in all matters pertaining to the day-to-day maintenance of an urban space, pays huge dividends for everyone concerned. With cities looking at huge population increases in the times to come, IoT-based smart city solutions will prove to be an indispensable ingredient in making urban environments safe, livable, and ecologically sustainable. 4. Advancements in edge computing. The reduction in cost and the increased power of the devices used in the IoT makes it likely to use the enhanced computing power of the devices to process data collected on the edge and allow huge bandwidth profits. Besides, in many cases, it secures greater compliance with privacy laws. Edge nodes and gateways, connected to IoT devices and systems, help them reach various types of data centers. IoT data often has to travel long distances from the data center to the device. Yet, empowered by the edge computing technology, it will less likely experience low bandwidth or increases in latency. That's why the number of enterprises investing in the edge technology keeps growing. This way, the accuracy and quality of real-time insights are expected to go sky high. 5. Blockchain technologies shaping the future of IoT. Blockchain is one of the key IoT technology trends as for today. The exchange of money and data between IoT devices in a reliable way is becoming possible, once the blockchain technology provides them with a simple infrastructure for doing so. Put together, the two phenomena, IoT and blockchain, are living up to their hype. The fragmented nature of IoT matches the decentralized nature of blockchain. The latter affords anonymity and security to multiple networks and their owners, while the digital signatures and private keys following each transaction guarantee that the IoT environment will be safe. IoT devices are designed to make the life of a person or an operating unit easier. This requires the constant generation of personal data and implies more considerable risks of hacker attacks. Besides, the amount of data is expected to expand exponentially, in the same manner as the number of machine-to-machine interactions. Consequently, the distributed nature of blockchain will make tons of data available at any time when it is needed and with the minimum security risks. 6. Healthcare applications. The future of IoT will assist in enhancing better control of medical parameters. With the help of 5G, AI, and sensors, it will be easy for medical professionals to monitor patients' activities and vitals. Smart glucose monitoring system and smart insulin pens will also help, as they will transfer the vitals of the patient automatically onto a monitoring system. This will be a guiding aid, especially with the case of insulin. Based on the data driven from the patient, the pen will be able to analyze the amount of insulin required to be injected. With the ongoing COVID-19 pandemic, the entire world has had to reevaluate the importance of remote healthcare. Security and safety are paramount in the clinical environment, and IoT can help by improving monitoring and transmission of patient data. Soon, patients and doctors will not even need to meet in person, which could be extremely useful in times of lockdown. In the near term, IoT trends will have a greater influence on the healthcare industry, with smart medical devices becoming more common. 7. Better way to data store and analytics. We've only just gotten used to keeping our data in the cloud, and it's already time for a change. Simply put, edge computing allows connected devices to share, calculate, analyze, and keep data locally. Edge computing is a kind of hybrid approach to data processing that's reshaping the future of IoT. Managing and analyzing this data serves the real added value that IoT can cause. Data analysis, machine learning, and artificial intelligence will hence play an increasingly significant and crucial role. These trends will not only provide effective processes to accomplish tasks, but also support in making our lives easier and more convenient.
Okay, so the video is finishing, but I have to interrupt in the last stage. Don't worry, because there is the advertisement of Future Young. So don't worry, because you have already seen all the 7 trends associated to the IoT technology. We can move with our conclusion. So to wrap up our session today, we have briefly introduced the technology of the Internet of Things. We have spoken about a brief history of this technological advancement. We have provided some definitions of IoT. We have also described the key components. We have spoken about the fundamental layers of IoT, of the IoT architecture. We have seen some applications and business use cases. We have dealt with the benefits of IoT, and we have also stressed the challenges and risks that have to be observed with this technology. And lastly, we have defined, we have interpreted the IoT technologies in different business domains, like data collection, data analytics, cloud computing, artificial intelligence, cybersecurity, smart homes, smart cities, and smart transportation. As always, I collected useful bibliography that you can consult for your own sake, for the sake of this lesson. This bibliography is composed by journal articles, books, and websites. So many thanks for your attention, and see you at the next lesson.